You're tuned into another episode of the AER podcast. Streaming on Apple, Google Play, Spotify, iHeart, and YouTube, this podcast features interviews of individuals in the coatings industry. Listen every month wherever you get your podcast. Stay in the loop by following us on Instagram and Facebook at AirEquipmentSA. Subscribe, rate, and visit us online at air-equipment.com. Now, enjoy another episode of the AER podcast. Hey everyone, welcome back to another episode of the AER podcast. My name is Jason Weber. I'm your host. This episode, we're going to be talking about the Amphiblast vapor blaster from Schmidt Abrasives. And today I got two guys from Axxiom Manufacturing with me. One that you've heard before, Bill Nelson, and another one that he's new to the podcast realm, Chad Lindquist. Hey guys, how's it going?
Doing fine, man. Glad. Thank you for having us.
Thank you, Jay.
Yeah, well, Bill, we had such a good time last time. I wanted to bring you guys back.
Yes, sir.
And then on this episode, you know, something that we kind of touched on in our previous episode, Bill, but it's a newish line of abrasive blasting, and it's kind of taken over the market. Wet blast, water blast, vapor blast. There's multiple different names for the type of application, but the one that Schmidt is the manufacturer of is the Amphiblast unit. So that's kind of what we want to talk about today. And I guess just jumping right into it, what is the Amphiblast?
Okay. Well, just for clarity, with all of the different monikers of different types of slurry blast and all of the different terms that are used out there, just for simplicity's sake, we've just started calling it wet abrasive blasting. And in the wet abrasive blasting world, that has been around for a long time. Lord, we were building vessels in the early 90s for as an OEM account, where people were mixing water and abrasive in vessels, all the way back to the early 90s, and I'm sure that there were some that predated that. So this really isn't new, but what is new is it's been resurrected, and it's really become quite popular because people are wanting to keep the nuisance dust under control by adding a little bit of water with their abrasive at the nozzle to keep that dust from going airborne. So when we Axxiom decided to build a Schmidt product in that realm, we studied the majority of the technologies that are available out there for strengths and weaknesses, and what we determined the best way to go through was to not have a piece of equipment that was solely relegated to wet abrasive blasting, but also give the operator the ability to blast dry with the same unit. That's where Amphiblast, amphibious or wet dry blast came from. And we released our first units, probably 3 years ago, and we have had great success with the Schmidt Amphiblast. It has been very well received in our market worldwide.
Okay, so you said like it's basically for dust suppression, but also the dust suppression is what we've noticed in more rural areas. I guess people go with the dry blast just for cost, but once you get into the more urban areas, when air quality becomes an issue because there's a heavily populated area, I guess that water injected or vapor injected blast unit, that's kind of where you see that, right? When you're talking air quality, to keep that dust out of the air.
Correct. And there might be other reasons that the contractors want to use a wet abrasive blasting system, but by and large, the name of the game is keeping that nuisance dust out of the air to keep wind drift from taking it over off of the job site and becoming an irritant or a problem for the HS&E on those job sites. And I have to admit, we were pretty skeptical at first, but this technology has been well received. It seems like nuisance dust has become a much bigger problem in our marketplace, or at least recognized it as a problem in our marketplace much more today than where we were, say, 10 years ago. A much larger section of our industry is moving to wet abrasive blasting simply for dust control.
Okay. Yeah, and you mentioned that the Amphiblast is both, you can blast both wet or dry. So other than that, what are the, how does the Amphiblast unit differ from other, some of these other water injected blast units you see out there on the market?
Okay, well, the majority of them have what I call a wet tank technology, where you actually add water in the vessel and finish filling the vessel up with abrasive. So you actually have a wet abrasive in the vessel, to where they use water pressure, hydraulic pressure, water hydraulic, not hydraulic oil pressure, to push that wet slurry out of the vessel and into your blast air to be conveyed down to your nozzle. We went a different route. We stayed a dry tank technology. It's based all on the tried and true Schmidt controls. So our Amphiblast control package is no different than our dry blast package. And that was important to us for a couple of reasons. One, the world is used to using Schmidt blasting equipment, so your operators know how to work on it. They know how to utilize it. They know how to operate it safely. It's the same type of controls that they've been running before. On the hydraulic or on the wet tank technology, the controls are very different. As you can imagine, they're using hydraulic pressure by a water pump to push that slurry out. So operators in the field have to learn a different control system in order to operate and maintain those other alternative wet abrasive blasting units. What we did is that we figured out how to precisely inject water into the airstream at, I guess you call it, a critical point, which is just downstream of the metering valve, instead of injecting water out by your nozzle. The reason that that's important is that where we inject the water, the abrasive is not up to full speed. It has just entered that airstream and it has yet to reach maximum velocity as it goes through that blast hose. So we determined that that injection point was critical to allow us to know how much water was needed to saturate that abrasive enough to keep that nuisance dust under control. If you were to inject further down at, say, at the nozzle, like many people have for many years, the old halo nozzles and water injection rings, those have been around for 40 years. Well, that technology is trying to wet the abrasive at its maximum velocity right before it hits the substrate. So they're having to put a lot of water out, because you're more or less trying to wet a bullet right before it strikes or right as it strikes your substrate. Those particles are moving. So that type of technology, you'll typically see 3/4 of a gallon, if not a gallon, of water per minute on the surface, just to wet that abrasive to the point of satisfactory dust suppression. where we inject our water and the method with what we do, we're frankly operating, normally around about a half of a pint. I'm sorry, about a pint or a half of a quart per minute. So the water consumption on the Amphiblast is much more finite and gives you much more control than a lot of the other product offerings out there.
Okay. Yeah, do you see anything, injecting it right after the metering valve versus at the nozzle? Do you see anything in material waste or material saving, or is it just the amount of water that it needs to be used?
Well, your material savings, and I know a lot of people in the wet abrasive blasting world are off on that, but to be honest, what I find is that the Schmidt controls on a dry blast unit allow you, if you operate it, as we preach and teach that you should, the abrasive consumption is right at the same, but your operator has full control of that. And a lot of applications out there, run more abrasive than is necessary in a dry blast. But those same operators, given a wet blast, have a tendency to run that unit lean. And with what we preach as lean on that nozzle on abrasive, just enough to cover the target area. And I got to tell you, Jason, I was confounded for quite a while trying to figure out why, if I give a man an Amphiblast and we set the metering valve as lean as we preach and teach to operate, and as long as he's running wet, he would run it like that all day. But as soon as I shut the water off and that blast hose dries out, same settings on the metering valves, and that operator goes into a dry mode, he's asking for more abrasive. And it took me a long time to figure this out, but we finally figured it out. Most operators are accustomed to running their dry equipment with what we consider too much abrasive, to the point where you can see abrasive coming out of that nozzle. And if you can see it, that's too much abrasive. You are having wasted abrasive, and you're creating a dust plume out there that you just don't need. Well, when we add water to it, they no longer can see the abrasive coming out, so their eyes are satisfied. They're used to seeing dry abrasive coming out. Now they have this water plume coming out, so they can see something coming out, although it's not abrasive. So they're willing to run a wet nozzle leaner than they are a dry nozzle. And it's an optic effect for these blasters, and it's really been interesting once I figured that out. So in a sense, the people that are out there expressing a cost savings of abrasive, by and large, that's true, but it's not because of the technology, and it's not because of it's not because of the equipment's ability to run rich or lean. Our equipment will run however you set it, but it's more of a matter of the operator being willing to run that vessel lean and still get the optic effect, seeing that water come out of the nozzle. So that's a long answer for your question. In the field, yes, I am seeing abrasive savings without a doubt. But I'm still going back to the contractors out there are really more concerned about how much water they're getting out of that nozzle per minute or per hour. Because as you can imagine, the blasting out there is pretty easy. Cleaning up that workspace after blast is a much more arduous job. So if you're running an Amphiblast at a pint a minute, the abrasive that operator's standing on, the spin abrasive, most of the time it's actually dry in a matter of 5 or 10 minutes. So it can be swept up and shoveled up and bagged up for disposal. With a lot of the other wet abrasive blasting units, the saturated tanks or the wet tank technology, you can't lean that nozzle out on the water. So you're really getting, pick a number, a quart of water a minute, if not more. So the operators during their production run are actually standing in a level of sludge out there that now has to be shoveled up. And, so they're having to shovel up mud instead of sweeping up abrasive.
Right. Okay. And that's if it doesn't go running down the, half a mile away from you.
Absolutely.
But kind of jumping back on the running your pot to, or not lean enough in the dry blast. As a distributor, I just got to plug this in there, but that comes back to being properly trained on your equipment. I think there's too many times where you see people buy stuff and not, especially in this industry, and not get trained up on it. And, you either stuff can go horribly wrong. That's not a horrible example of it, but probably would cost you some money over the years of, spending on extra abrasive. So that's something I hadn't even thought of. But I guess, yeah, what you're saying is, because they can see that water coming out of the end of the nozzle, it satisfies them because they're used to seeing the dry abrasive coming out.
Correct.
Okay.
Correct.
So that'd be, I guess we covered the benefits of injecting it at the metering valve instead of the nozzle. Now, what are the benefits of injecting at the metering valve instead of within the pressure vessel? Other than, I guess,
okay,
the main benefit, I guess, would be you can switch from dry to wet, right?
Well, true. Well, and let me back up. There is one other point that I want to point out. When we inject just upstream of the blast hose, right at the metering valve, one of the benefits is that I get to use the length of the blast hose as a mixing chamber. And that's one of the reasons why I'm able to get down to a pint of water a minute, because as it traverses the length of the blast hose to get to the nozzle, it's actually in a slow spin in there, and it has enough resonant time in the blast hose to get a proper wetting of each particle. So that's kind of the last little benefit of injecting at the metering valve in lieu of the nozzle.
Okay.
Now, some of the benefits that our Amphiblast has over some wet tank technologies, quite frankly, one of them is how much water. When you have a vessel full of a mixture of abrasive and water, and you extrude that wet abrasive out of the vessel into the blast hose, you are going to receive a predetermined amount of water. And that's just a fact of life. So logic would say that the finer the abrasive, the less water you're going to get per, quote, pound of abrasive into your airstream. The coarser that abrasive, because there's more voids in between the particles, you're going to get more water with a coarser abrasive. So with the wet tank technology, you will receive a predetermined amount of water, whether you need that much or not. And all you can do is add more. You can't back off of how much water you're going to receive. With Amphiblast, you have finite control of it. You can go from all the way off to flooding the nozzle. It's up to the operator. So that's probably as big of a benefit that the contractors have expressed to us, is that they can run less water and make their job site cleanup that much easier. The second biggest differential is that with a wet tank technology, you're limited in how coarse of an abrasive you can go with. The reason is that if you put a coarse abrasive into that wet tank, you have to build water pressure up on top of that slurry of abrasive to push that abrasive out of the vessel into your blast hose. Well, if the abrasive is coarse, the water won't just build head pressure on top of it to push it out. The water will actually sieve through the abrasive and exit the vessel without creating that head pressure to push it out. My field experience, I have not done any empirical study on this, but my experience in the field is that wet tank technology starts having trouble feeding a blast hose at about 36 grit. Anything coarser than a 36, I have not seen successful runs. With the finer abrasives, it'll build the head pressure, it'll push it out. Okay, you know, the equipment does what they say it will. But when it comes to coarser abrasives, there's a nuance about it people need to understand. With the Amphiblast, it's a dry pot. If it'll run through a dry pot, you can run it through the Amphiblast. I don't care.
Okay. And you've seen, because most of the I guess the other blast pots or vapor blast pots I've seen, they recommend using most of the time what I see is recommend using garnet. But you're saying with the Amphiblast, if you can dry blast with it, you can also wet blast with it?
Sure.
Okay.
Yeah, I run everything from sodium bicarbonate to one guy wanted me to run steel grit. I don't understand it, but that's what he wanted. We ran it. Aluminum oxide, corn cob, walnut. I mean, yeah, if it'll go through a dry blast pot, it'll go through the Amphiblast.
Okay. All right. Now that we discussed the Amphiblast, let's kind of talk about the different buying options that the Amphiblast comes in. Just looking at your website, you have the Amphiblast, Amphiblast Light, Mini Amphiblast, and the Bulk Amphiblast. What are the kind of different options with each, I guess, version of the Amphiblast?
Chad?
So we started out, Jason, our two original units were a skid mount type with an onboard water tank, and that would have been our 4.5 cubic foot single outlet unit. And then we have, or started out as well with our 6.5 cubic foot dual outlet configuration, where you can actually blast with two operators off of one unit in one vessel. We've since graduated and broadened the family spectrum, so to speak. Again, we go from a 1.5 portable type with a 15-gallon onboard water tank to a 3.5 cubic foot portable type with an onboard 15-gallon water tank. And then, of course, your single outlet skid mounted unit in the 4.5, the 6.5 dual outlet. Our first bulk unit configuration consisted of a 3-outlet 52 cubic foot unit that you could actually blast or utilize 3 nozzles on, have 3 operators running off one unit. And since then, we've graduated up to the 6 and 8 ton, the 120 and the 160 cubic foot units, with a variety of different nozzles from 2 outlet all the way up to 4 outlet. And what's really unique about the multi-outlet units is that each operator can operate independently of one another. So our Amphiblast technology consists of the ability to blast dry, ability to blast wet, and we also offer a wash down feature where you have the ability to sufficiently wash down your substrate after blasting. And then we offer on the unit a dry off mode where you can isolate your abrasive and your water and just have air only if you want to blow off the substrate. So on our multi-outlet units, what's really significant and unique is that each operator has the ability to operate in any of those configurations independently. So you could have 2 operators or 1 operator inside of say a ground storage tank blasting dry, while the others are outside blasting wet, or any 4 combinations that you want. So it's really unique in that way.
Okay. Yeah, I was actually going to be, my next question was, can you blast wet and dry simultaneously on the multi-line blast units? I think that's a really big benefit that people would get from buying one of these bulk units, or the I think you guys make a dual line also.
Correct. We have the 6.5 standard dual outlet unit, and then again we've built units in the 120 cubic foot, 2 outlet, 3 outlet, 4 outlet. So in the multi outlet configurations.
Okay.
And Jason, that brings up another point that I kind of overlooked. Our technology, dry tank technology versus the saturated or the wet tank technology, because they're using hydraulic pressure to push that abrasive out, that vessel is 100% full of water whenever that vessel runs out of abrasive. So that operator has to dump about 50% of the water out of the vessel in order to put the next load of abrasive in the vessel itself. And to be honest, I don't know what they do with that water, but I have a hard time believing that they would recycle it, because that water is still going to have abrasive in it from the vessel itself. So when you really start talking about water consumption, just understanding the fact that you got to dump half of the water out every time you refill with abrasive, that really should be taken into account whenever you start talking about total water consumption, if that makes sense.
Yeah. Okay. Well, I had a couple other questions that just kind of popped into my head. One, I want to talk about the compressor size to run these blast pots. I know in some of the other ones that we've run into, they take a minimum of like a 375 CFM compressor, and that's because it takes extra air to pressure up the tank, I guess. But is with this one, since it is a dry or wet blast, is the size of your compressor still predicated by the size of your nozzle, the blast nozzle?
That's correct. Yeah. I can't speak on the wet blast or the wet tank technology requirements in terms of compressor size or requirements, but on the Amphiblast, the same rules apply to the Amphiblast as it does traditional dry blasting. So your air supply is going to be predicated upon what size nozzle you run and what other accessories are being pulled off of that air source, say you're breathing air and such. So there's no added need for CFM other than what you're already accustomed to in a dry blast scenario.
Okay. And then kind of spin off of that, do you see is there a minimum size nozzle you can go with injecting the water in, or is it mixed so well with the water that you don't see it kind of clog up a smaller nozzle?
Jason, I personally ran 1/4-inch angle nozzles on the Amphiblast. At one point I was running a number 3 nozzle with the Amphiblast, but the only, I guess, warning or the only fact that I would roll into that question is, as I say, no, I've ran about every size nozzle that you can. When you're running in wet blast, your hose diameter relation to your nozzle is all the more critical. So you can't sit there and put a number 3 nozzle on an 1 1/4 hose. The abrasive won't travel the hose fast enough to stay in the air. So it will fall out in the hose and become clumpy, and it'll start puking out of that nozzle. But as long as you make sure that your blast hose is no more than 3 times the diameter of your nozzle, I've ran number 3 nozzles successfully, dry and wet, out of the Amphiblast. Of course, I was running fairly fine abrasives, your 80 mesh, your garnets, and your Starlight products and such. So as long as they ensure that they're running the right size blast hose for that nozzle, no, there is no restriction.
Okay. Yeah, and then one last question I had, and this is just, it kind of popped into my head. I've heard this, I guess, myth or legend in the past. You guys are in the Houston area, so you're well familiar with humidity. And I've heard that when you're blasting a substrate, if you use reverse osmosis water, it'll prolong the rust time before in between coating. Is that true, or is that just a myth?
I have not personally witnessed that. I've heard the same rumor as well, and I'm calling it a rumor because I personally have not witnessed it. I have a hard time believing that is true, but I have seen the water additive products out there that can be mixed in the water tank of the Amphiblast, just like you can the other wet tank technologies. And I have seen those water additive products successfully hold that blast. But as far as just running, an RO type water, I haven't seen that.
Okay, that seems like it'd be really expensive anyway. Probably just by rule of thumb, once that substrate's dry, go ahead and put a coating on it.
That's the way I see it, but,
yeah.
But I'm not a contractor either.
Right.
I'm just an old, I guess you call me an equipment guy. I'm not an applications guy.
Okay. Well, yeah, guys, that's all I got today. I don't know if you have anything else you wanted to add before we take off.
No, I certainly appreciate the opportunity, Jason.
As do I, buddy.
All right. Well, if you guys want any more information about the Schmidt Amphiblast units, feel free to contact Air Equipment at 210-223-3157 or visit us online at air-equipment.com. Bill and Chad, I want to thank you one more time for joining me today. I think we got some real good knowledge out there on the Amphiblast units, and yeah, just appreciate it, guys.
Thank you, Bo.
Thank you, Jason.
All right. Thank you, everybody, for listening, and we'll see you on the next episode of the AER podcast.